this subject is going to be a little bit different than the previous, but we are still talking about words. Still, we are talking about words in CVEs, and we are going to talk about CVE checking and entire distribution. I'm wondering if it ever happened to you when working on your project that you wanted or you needed to check the whole of your distribution for known security issues. Or you needed, or someone requested you to do security reporting, including things like which layer has how many issues, and also later to monitor them over time, to tell how many new and removed issues you have, how many security issues are above some severity level. If you have had such questions, in fact, you have had the same questions as we have in Oniro. Quick introduction to Oniro. Oniro is an Eclipse Foundation project and a distro for IoT embedded consumer industrial products. Of course, it's based on OpenEmbedded and the Yocto project. That's why we are talking about the common tooling. And the specific feature of Oniro is that it supports a matrix of scenarios, both on multiple OSs, at least Linux and CVE and more today, and multi-boards, so we have a big matrix of supported platforms. About an hour ago, Andre did a presentation about this. If you haven't watched it, you will be able to go back to the recording and see more information about it and the demo. But now we are going to talk about the CVEs, so I would like to refresh some terms related to the subject. First, a CVE. A common vulnerability enumeration, it's a standard for naming security issues. Please remember that this is for known issues only, and someone needs to request a number. It means that there are vulnerabilities in the nature without a CVE number. We name CVEs in a format CVE -year-number, like CVE 2022-12345, which is not assigned yet at this time. A CVE, I understand it as a ticket number. It allows people from different teams to talk about the same issue using some identification. Because, of course, you may have a number of issues in the same package discovered more or less at the same time, and you are fixing all of them at the same time. If you want to ask a question, is that specific issue fixed? Well, it's easier to use the CVE number to be sure that you know what you are referring to. There is a new website about CVEs, the cve.org, that has been reworked recently and allows you to query the database to look how it looks like. And then there is a second database called NVD, National Vulnerability Database. I have been talking about the CVE database. You have seen on the slide how to find it, and you have probably already used it, even if you haven't heard me correctly. The second database is NVD, National Vulnerability Database. It includes the same information as the CVE database, but it includes some additional data. It includes product names about which product is affected by which issue, and it includes some references to fixes, advisories, and other information like that. And it's important in our case to talk about the NVD database because the cve-check in Yocto, it is exactly using this database. You can have a look at the website of the database, and we are going to have a short look at an example entry. I have chosen a free type issue that have been handled on the mailing list like a week or two ago. And I'm going to follow the whole page of the issue so you can understand how to read it. So it starts, of course, with the ID of the issue. Then this one has a note that is under analysis that may take time and may change some of the information. So if you are interested in this one, it may be interesting to have a look in some time at the website to see if something changed. Then you have the description that is telling you different things depending on the issue. It is telling you more or less what the issue is. Here we have a clear information that's buffer overflow and introduced in some specific commits. So it's should be pretty easy to figure out, to identify it. Then we have the severity part, which is pretty important to understand how important and how serious the issue is. So there are two pieces of information here. The first one is base score, the easier to use at the first glance. And here what we have is the base score of 9.8, which means it's nearly as bad as could be because the maximum is 10. And then next to it, you have the vector. The vector contains information in more details about, for example, if it's a network-based vulnerability or if it's a local one, if you have to have access to the system or not. And there are decoders online that allow you to decode the strings so you can find out exactly what it means. But it's pretty, when you get used to that, it's pretty easy to decode manually also. Then when we look at the website, you get a very important part when you are looking for a fixed solution. That's the references. And in this particular case, what we have 3 links. And one of the links includes an issue on free desktop GitLab. When you have the patch, in fact, you have the link to the patch in there. You have the issue tracking, of course. So you can, and you have the discussion, so you can look into the issue more in details, and you have all the messages on this case Fedora mailing list about it, so you can learn more, and you can figure out if you are affected or not by this issue, and how to fix it. Then at the end, you have the part about the software configurations that are affected by this issue. In this case, we have 2 configurations. The first configuration is just the free type project itself. In this case, the bug is marked as happening up to version 2.12.0. Excluding that version, it means it's fixed in this one. And you also have information about the distribution that is affected. In this case, you have Fedora. I'm not quite often using the information about distributions because it's quite often incomplete. Usually it's just the distribution that reported the issue and doesn't include every single distribution and status of every single distribution. But it could be interesting because that distribution may be having some more documentation about it, so could be interesting. In our case, for Yocto cve-check, what is the most important is the project itself entry. And now, why would you do a cve-check? You would do it to find out which packages, libraries, other dependencies you need to upgrade, or looking at it differently, which would be ideal to get rid of absolutely because they have too many bugs. Then you will be probably updating your information quite regularly, in fact, because new issues go public every day, and the NVD database is updated typically once per day. Also, a good practice is to mix the CVE-check approach with other solutions like hardening or static analysis or other security measures that you have, because, as I've said, the CVE shows you only what is known as being broken. It doesn't tell you about things that are going to be broken in 3 months. Let's now enable the CVE-check in Yocto. This is pretty simple. You just edit your local conf, add inherit to the CVE-check class, and then build your image as usual. It will download the database. There's a specific task for it, and they will do the check for all the recipes you have, typically 1 to 3 minutes on a typical system. As a result, you get log files for every recipe, and you get a common log for your image. At least that was the situation before the machine readable format. How does the format look like? This is, of course, an example and a fragment of a file. It's pretty understandable. You have the layer, package name, the version, and then you have entries for every single CVE. So you have the CVE identification, you have the status, description, the score, part of the vector, you have a link for more information to the NVD database. Now, that is pretty nice. You get all the information that you may need. But why we wanted to add something more? When you are checking for one recipe, it's easy to post-process the file with some exceptions like the Linux kernel. I'm joking because typically it takes about half of the whole CVEs of your build. And you want to post-process, you have to find out what you have, run statistics from it, and the text-based format is not the easiest one to post-process correctly. So we decided to add machine readable format, and then why JSON? There are other formats to try out. We went for JSON for 2 reasons. First is because the related tools are already using JSON, especially the SPDX tool, SPDX generation. And we expect that those two are going to be used together quite often in the future. And then the new CVE format that's going to be deployed in the version 5 this year, it is JSON and includes quite many data fields from the NVD database. So there would be probably some kind of a migration at some point, and we can reuse when we have a similar format for the data. So with the new format, you have 3 main variables that control the whole generation. You have the CVE-check format text that is just enabled by default, and that's the format you had until now. Then you have the new format, new JSON format that is enabled by CVE-check format JSON. It is enabled by default in master and Kirkstone, but it is disabled by default in Danfor to keep it compatible with the previous state. And then we have the coverage statistics that is done only in the JSON format, and that is enabled by default. And then a few words about the coverage statistics itself. You may know that the package name or the recipe name that we use in OpenEmbedded Yocto project, it may differ from the name that is used for vulnerabilities. And that leads to a number of possible issues, and is related to the fact that the old format was missing certain information. First, for me as a security person, the old format was missing packages and recipes without any CVEs. And it happens that the fact that a package has no CVE reported, it's just to the fact that there is a name mismatch between what we have in the recipe name and what we have in the NVD database. Surprise, you have vulnerabilities that you're not aware of. What is sad. So it's good to fix those issues. And then the other subject is we do not know which product names are actually used in the NVD database and which are not. This is more for security research in this case. And then let's have a look how it looks after the conversion in the new format. So the keywords are the same. It was to keep it as much compatible as possible, but with some additions. You have the products table that is listing all the products that are defined for each recipe, and you have information if it has issues for this name or not. And then instead of listing each issue with the recipe name, you have a separate issue tables with all of the issues that are listed there, and you can post-process that. Now, when we were working on that, we found out that the CVE-check as it is, it's worked very well for a single recipe or a single image. But at Oniro, we have a number of images, so it's not very practical to run a CVE-check over a dozen or more images. And it also only verifies the packages and recipes that get included into the image or into the build, maybe. And we have no information about other things that are in the layers that we include. So we wanted to run the CVE-check for the world build with all the layers that we include. And that resulted in some fixes upstream for the places that were not exactly working as they should be. And there are some more things that will be coming. The next step on our side is more tooling. The format is there now, and now we are working on how to make it useful. The processing of a JSON file is pretty simple, so you can extract what you want. We still have some pending issues with some layers resisting CVE-check. Our favorite example currently is MetaZephyr. We need to run all the CVE-check because it does magic with stamps. We have issues with generating the final file correctly on Word, and still same layer is pretty good example. We currently have problem with scanning recipes that download multiple libraries, tools in the same recipe. So we currently check only the main part of the software, but not all the other things that got downloaded. And related situation, if the upstream project is copying libraries into the source tree, we are not verifying those copied libraries. And that could be a pretty big source of issues. You have probably heard about the log4j exactly library that could be copied everywhere. And this, and we know that there are some quite popular libraries that often have vulnerabilities. So solving that is pretty complicated, but it would really help. For this work, I would like to thank to some people who contributed. We have Davide, who was working on the word check, Andre, who helped with various low-level bit-bakey subjects all around the place, and Steve for discussions about the reporting scripts, how we can improve them. Once again, you can now get the CVE-check output in a JSON format from the Kirkstone branch near you, or from Dunfield branch, or from the master branch near you. So it's at your fingertips. If you want to see more work that you are doing at Oniro, do not hesitate. Visit our project website on the project website on Eclipse. All the source code is in Eclipse GitLab, and also the communication channels if you want to contact me and on any other team member. We have mailing list, we have channel at LiberaChat. So it's easy to contact us.